Hi, this is Mr. Adams from Middle High School, and this is a video on naming and writing alkenes. Once you can name and write alkenes, you also can do the same thing for alkynes. All right. The rules of naming and writing alkenes follow those basically of alkanes, right? And we can review that in our notes or on the previous video. In terms of alkenes and alkynes, the double and the triple bond, you must have them with the lowest possible numbers in terms of the parent chain, okay? And if they give you a structure to name, right, the double or triple bond must be included in the parent. You can't have for example, a double or triple bond and ignore it from the parent, okay? That's a major violation. All right, so moving on. We have two structures here, and we notice right at the bat that we have double bonds in them. Okay, so we're just going to simply name them. All right, this guy right here has 4 carbons, right? So the prefix of 4 is simply but. Now, once again, that information is on your reference table. Now, the fact that it has a double bond will give us a suffix E-N-E, indicating it's an alkene. And you have your reference tables to help you, table Q, I think, that helps you with alkenes, alkanes, and alkynes, if you forgot the names of the particular guys. Now, before we wrap this guy up right here in the corner, we must indicate as to which carbon the double bond is coming out of. So we know this is carbon number 1 right here, and carbon number 2, 3, 4. So the lowest number carbon is coming out of is carbon number 2. So we simply call this guy 2-butene. Now notice if we count from this direction now, okay, it would also be 2-butene also. So either which direction, it doesn't really matter in this case. Okay, so but we always check our directions. Now on this other guy to the right, we have to name it. So what we simply do first, we get the longest, okay, continuous chain possible, including the double bonds. Now, once again, we'll look from this direction, and we'll look for this direction to get the lowest number possible for our double bond, right? And it seems as if we count from right to left, we'll get 1, 2, 3, 4, 5, where our double bond is coming out of carbon number 2. Okay, so 1, 2, 3, 4, 5 will give us pent. All right, the fact that it has a double bond gives us ene. Alrighty, okay, and since it's coming out of carbon number 2, the double bond, we simply say 2-pentene. Okay, so we have double bond coming out of carbon number 2. Now we're not quite done, because here we have a group, a 1 carbon group hanging out the side, which is called a methyl group, an alkyl group with 1 carbon, and that's located at carbon number 3 right there. So we simply say, okay, our final name is going to be 3, okay, and let me just clear that off a bit, 3, okay, dash methyl, dash 2-pentene, and we're done. So that's the name of that guy right there, 3-methyl 2-pentene. Very easy. Okay, now moving on to actually drawing the structural formula for this guy right here. Right at the bat, we see we have hept. So we go 1, 2, 3, 4, 5, 6, 7. 7 carbons, hept, and ene represents the fact that we have a double bond someplace. Now that double bond will be coming out of carbon number 3, hence the name 3-heptene. So let's go from the left to right. This is carbon number 1, 2, 3 right here. So we'll put our double bond right there. Okay, so now we have a double bond coming out of carbon number 3. Now we also notice we have 4-ethyl, right? So what we simply do, we count 1, 2, 3, 4. Okay, we can put an ethyl group right there. F means 2 as a prefix, and we're basically done. So what we do after that, we put our hydrogens in carefully. Now I'm going to use lines to represent hydrogens, folks. Okay, so this guy right here is 3 right there, so that gives that carbon 4. I'm going to put 2 more right there. I'm going to put 1 right there. Now